Welcome to the ROBILE assembly tutorial by KELO Robotics. In this part of the tutorial, I'll show you how to access the ROBILE computer, modify the configuration file, and move the robot using a joystick. I am using a PC with Ubuntu OS and Nano text editor to modify the ROBILE configuration file. However, you can use other alternatives as well. Let's get started. Step 1. Accessing the ROBILE computer. The goal is to access the ROBILE's computer from your computer to check and modify its files. First, turn on the robot. Then, connect an Ethernet LAN cable. Plug one end into any of the 4 slots on the robot. Connect the other end to your laptop. Then, set up your computer's IP address. The robot uses a static IP address. Open your network settings and set the IP address manually to something like 192.168.1.x, where X is an IP address which has not been taken by other devices in the local network. ROBILE PC is set with a static IP address, which is 192.168.1.102. Then, open a terminal by pressing Ctrl+Alt+T on your computer. Then use the command ifconfig to list IP addresses of your network interfaces, like Wi-Fi or Ethernet, and to check if the IP address of your machine has been set correctly. You can ping the robot's IP address to confirm the connection. When you ping the robot's IP address, your computer sends a small test message to the robot. If the robot is connected properly, it will reply back, showing that the connection is working. If there's no response, your request would be timed out, which means your computer cannot reach the robot. You might need to check your network settings or cables. Now it's time to access the ROBILE computer. You should use a secure method called SSH, Secure Shell. This allows you to open a remote terminal on your computer and control the ROBILE system remotely. To install SSH in Ubuntu, you can open a new terminal by pressing Ctrl+Alt+T and then enter the following command. And then type your password to give permission for the installation. SSH KELO at 192.168.1.102. Finally, enter the default password, which is KELO. All letters are in lowercase. Once logged in, you now have remote access to the robot system. KELO Tulip. Step 2. Viewing and editing the KELO Tulip configuration file. Once logged in, you need to check and modify the KELO Tulip configuration file to ensure that the robot's wheels parameters are correct. This is the default configuration file for KELO Tulip. It has been created for a ROBILE with 4 wheels. Each wheel has 3 key parameters. Slave number identifies the wheel's ordering in the EtherCAT chain. XY coordinates defines the wheel's position relative to the robot's rotation axis. Pivot angle determines the wheel's orientation. Step 2.1. Assigning the correct slave numbers. Adjusting the configuration for your robot. Does your robot have fewer than 4 wheels? Edit the number of wheels and comment out the unnecessary wheel parameter sections. Does your robot have more than 4 wheels? Increase the number of wheels and duplicate the wheel parameter sections. Once you have adjusted the number of wheels, the next step is ensuring that each wheel is assigned the correct slave number. To verify this, first, run the RUS launch file. You may see an error message if the slave numbers are incorrect. Second, check the product numbers. All wheels share the same product number. In this case, 33558529. Third, identify the correct order. The wheels are connected in sequence. The first wheel connected is assigned the smallest slave number, in this case, slave 3. The last wheel connected has the largest slave number, in this case, slave 9. Finally, update the config file with the correct assignments and rerun the launch file. If no errors appear, the slave numbers are correctly set. Step 2.2. Setting the XY coordinates. After assigning the correct slave numbers, update the XY coordinates for each wheel. These coordinates define the wheel's position relative to the robot's center of rotation. Decide the robot's coordinate system. Choose a reference for positive X forward and positive Y left. Define the center of rotation, 0, 0, usually at the robot's geometric center. For each wheel, you need to measure the X-Y offsets. Each wheel's position must be measured relative to the center of rotation. If each robot frame brick is 23.3 centimeters, and the wheel is positioned half a brick away, then X equals 0.233 meters. Y equals minus 0.1165 meters. Repeat this for all wheels and update the configuration file. Step 2.3. Defining the pivot angles. Each wheel has a pivot angle offset, which is its rotational offset relative to the robot's forward direction in radian. However, depending on how each wheel is mounted, its zero position may differ. The angle difference can be 1.57 radians, minus 1.57 radians, 3.141 radians. Please note that if the wheel's zero position aligns with robot's forward direction, then A is either 0 or 6.28. To determine the correct pivot angles, manually push the robot to align all wheels to the forward direction. Now if we read the encoder values, they show the wheel angles in radians. These values may not be exact, but since the wheels align to forward direction, they correspond to one of the possible A values we discussed. By interpreting the encoder readings, we can determine the closest matching A value and update the configuration file with the correct values accordingly. To read the encoder values, open a terminal and execute rus launch KELO_tulip example_joypad.launch. Read the encoder values to see the pivot angles. Open a new terminal and execute rustopic echo/platform_driver/wheels_input. Stop the launch file by pressing Ctrl+C. And update the config file with a value closest to 1.57079, minus 1.57079 and 3.14159 radian. Finally, adjust the A value for each wheel in the config file to match the closest possible value to the encoder readings. Now that the configuration file is properly set, it's time to move ROBILE using a joystick. Step 3. Moving ROBILE with joystick. To begin, make sure you're using a compatible joystick with a supported RUS driver. Just keep in mind that you might need to modify the joystick driver configuration accordingly. To connect the joystick, plug the dongle into one of the robot's USB ports. Make sure the mode switch is set to D, and that the LED light is off, which indicates the joystick is in direct input mode. The dead man button must be held down at all times while controlling the robot. It acts as a safety mechanism. If it's released, the robot will stop immediately. To rotate the robot, press and hold the deadman button, then move the right joystick horizontally. To move the robot, press and hold the deadman button, then use the left joystick to move forward, backward, or sideways. With the joystick configured and your hands on the controls, you're now ready to operate the ROBILE robot safely and intuitively.